Hello, this is Arif Irfanullah, and in a series of short tutorials I will be presenting the most important functions of the Texas Instruments BA2 Plus financial calculator. This particular tutorial deals with time value calculations where we have a single cash flow. Specifically, here is what we'll cover. There'll be some comments on setup, then how to come up with the future value, present value, how can we calculate the interest rate if we are given the present value, future value and number of periods, and then how to calculate effective rates given a nominal rate. So let's start with the setup. The first thing that you should do is set the decimal places to floating decimal. The benefit of doing this is that the screen becomes less cluttered and you are only shown what you need to see. As an example, if we do 3 divided by 5, then with floating decimal you will just see 1.5. If you set decimal to, let's say, 5 places, then you will see 1.5 and then 4 zeros. So let's look at how this can be done. On the financial calculator, you click second and then format, and here you will see what the decimal places is set to. On my calculator this was originally set to 2. It might be a different number for you. But to change this to floating decimal, you press 9 and then enter. When you press enter, you see the equal to sign, which means that this number has been accepted, and then you do second and quit. Now the floating decimal has been set. The other important setup is payments per year. Generally the default is 12, which implies 12 payments per year or monthly payments, and I recommend that you set this to 1, and later on we'll see why this is useful. When we have 1 payment per year, then we can simply think in terms of periods, and then each interest rate needs to be for a period, and this will make more sense as we go through the rest of the tutorial. So let's see how to do this setup. We click on second and then payments per year, and here the number is set to 12. On your calculator it might be a different number, but what you need to do is change this to 1. So again you press 1 and then hit enter. The equal to sign means that the number has been accepted, and then you do second quit, which brings you back into the standard calculator mode. We will now come up with the future value of a single payment assuming annual compounding. If you invest $100 today, so at time 0 you invest 100, there is a 10% rate, so this is compounded annually, and we need to calculate how much we will have at the end of year 5. So how do you do this on the calculator? The first thing is to just make sure you are in standard calculator mode. So we are. If you are not in standard calculator mode, just click on second quit. Then make sure that the time value of money registers are clear, so second TVM. If you don't do this, then any numbers that already exist will be used. So to be safe, just do second and then clear TVM. Then we enter the data. We have 5 periods, so we hit 5 and then N. Notice that the equal to sign is there, which means that you don't have to hit enter. So the system has recognized that N is equal to 5. Then 10 is our interest rate, so 10 and then hit IY. Again this is accepted, and then we give the present value, which is 100, so 100 PV. The payments are 0, which means that no additional payments are being made during this 5-year period, so 0 payment. And then we compute the future value, so compute FV, and we get minus 161.051. Now this simply means that if we are putting in 100, then we are coming out with 161. Coming out is implying a flow in the opposite direction, that's why there is a negative. So for our calculation we can say that 100 invested for 5 years will give us 161.051. We'll now look at the future value of a single payment where there is quarterly compounding. Say you invest 100 today at 10% compounded quarterly. How much will this become after 5 years? The first thing to recognize here is that we have 20 periods. 5 years with 4 quarters per year, so that is 5 times 4, which is 20 periods. So in essence, we are saying that we have $100 at time 0, and what will this become at the end of 20 periods? Now recall that we set our calculator such that payments per year is equal to 1. This means that our interest rate per year is really an interest rate per period, and since the period is 1 quarter, the interest rate per quarter is going to be 10 over 4, which is 2.5. So here is what we do on the calculator. We first make sure that we are clear, so second quit, and we clear the time value registers. Then we enter the data. We have 20 periods, so 20n. The interest rate is per period, which is 2.5, so 2.5 is the interest rate. The present value is the amount we invest, which is 100. The payment is 0, and we compute the future value, and that is the answer. Next, future value of a single payment where we have continuous compounding. We invest 100 today at 10% compounded continuously. Here 10% is the stated rate or the nominal rate. The future value is equal to the present value into e to the power of rt, where r is the stated rate expressed in decimal. What this will then become is 100, which is the present value, times e to the power of r, which is 0.1, times t, which is 5. So this is e to the power of 0.5. Now on the calculator, we first make sure that we are clear, and then we start plugging in the numbers. Let's first plug in numbers for this expression. What we can do is punch in 0.5 and then second e to the power of x, so that gives us this expression. Then we multiply by 100 and we get our answer. Present value of a single payment with annual compounding. Now in this case you are getting this much money in 5 years. The interest rate is 10%. What is the present value? So times 0 times 5, interest rate is 10%. You will get 161.05. What is the PV? Again, you can enter the data. So 5n. The interest rate is 10%. So plug that in. The PV is what we need to find. The payment is 0. The future value is 161.05. 161.05 is the future value, and then you compute the present value, and that is the answer. We'll now calculate the present value of a single payment assuming continuous compounding. Say we get this much after 5 years, so this is times 0 times 5, we get 164.87. What is this worth today? We assume continuous compounding with a stated rate of 10%. Now here the formula is that the present value is equal to the future value times e to the power of minus rt. The first thing to do is come up with this minus rt. R is 10%, which is 0.1, t is 5, so minus rt will be minus 0.5. Now let's plug this into the calculator. The first thing is to clear the numbers and come into standard calculator mode. Then we plug in the numbers. So 0.5, and since this is negative, we hit the plus minus, and then second, and then e to the power of that, which gives us this number, and then we multiply by the future value, which is this. So multiply by 164.87, and this gives us essentially 100. So that is the answer. Next, we'll compute the interest rate per period given the present value, future value, and number of periods. if we invest 100 today and get this much in 5 years, what is the interest rate? The assumption here is that the payment is 0. So let's just plug in the data. We have 5 periods, so 5n, and then the present value is 100. The interest rate is what we need to calculate, so we skip that. The present value is 100. Payment is 0, so 0 payment. The future value is minus 161.05, so 161.05. We need to make this negative. The present value and future value need to have opposite signs. Then we compute the interest rate, and that is the answer. If you give the present value and the future value the same sign, so if you accidentally did not put a negative sign here, then you will get an error. Nominal and effective rates. Let's say that we are given a nominal rate or a stated rate of 12%, and we have quarterly compounding, which means that we have a 3% rate per quarter. What is the effective annual rate? The first thing we do is to get into the interest rate conversion mode. So how do we do that? First we just clear, and then to get into the interest rate conversion mode, we click second and interest rate conversion. The default is that we have a nominal interest rate of 0. What we do is make sure that everything is clear. So we clear all the registers, and then we enter the nominal rate. So that rate is 12. So just plug in 12 and enter. When you see the equal to sign, that means the number has been accepted. Then we hit the up arrow. This stands for the number of coupons per year or the count per year. If we have quarterly compounding, then this needs to be set to 4. So you set this to 4 and again enter. So now we have established quarterly compounding or 4 coupons per year. Then hit the up arrow and compute. The effective annual rate is 12.55%. This is saying that a nominal or stated annual rate of 12% is equal to an effective rate of 12.55% when we have quarterly compounding. Now if we want the effective rate assuming continuous compounding, then the tip is that for CY we just plug in a very high number such as 10,000, and that is going to give us the effective rate assuming continuous compounding. So that is it for this particular segment.